Then you had the
So we should begin. Hi, I'm Martin Elvis, and I have the pleasure of introducing today's speaker, Nick Wilding. I met Nick in Florence at a conference on the building a spacefaring civilization, and I think we were two of a very small number who were not medical doctors, so we got to hang out together. And he has interesting tales to tell, and I hope he'll be telling some today. So Nick is a historian of early modern Europe, history of science, and the history of the book. He's the author of two books, Galileo's Idol, Gianfresco Sagredo, and the Politics of and the Politics of Knowledge. It's a long title. Yes. And oh dear, Faussaire de Lune, or the Moon Forger, if I translate correctly. So that's another interesting side to what he does. He's had fellowships at the Medici Archive Project, Stanford, Cambridge, Columbia, American Academy in Rome, another nice place to hang out, New York Academy of Medicine, and the Rare Book School. So if you may have heard of him before, because his work on book forgery has been featured in the New York Times and the New Yorker. And I don't think he's going to talk to us about that today.
A little bit. Tiny bit,
okay. Instead, he's going to talk about fact and fiction, or how Galileo moved the Earth. Nick.
Thank you very much. So thank you, Martin, for arranging this. Thank you to everyone at the Center for Astrophysics for coming out today, and for honoring the legacy of Owen Gingrich, who was important figure in some of my research. We're living in a period, it might be too early to say, but it seems that we're in a period of assault on science in general, higher education in general. So the talk today is really trying to get us to think historically about other moments when science has been in crisis, and what kind of resources science uses to validate itself when that has ceased to be self-evident to other groups. This talk will be looking at a very specific set of documents, a very closely defined event in history, Galileo's first astronomical observations using a telescope. So we're looking at only a few months in the winter of 1609 to 1610. And I want us to look quite closely at a few different documents so that you can get a sense of what the raw data that historians use looks like, how we decide what to filter into our data set, upon what criteria we exclude materials, how we can get that wrong quite spectacularly in some of these cases, especially when forgeries come along, and how the interpretations that we make, the stories we tell, the histories we write, depend very deeply on those early choices of which kinds of documents we prioritize. I don't want you to come away with the idea, even if I include a fair number of forgeries here, that history is riddled with such documents, and that it's the kind of nightmare scenario that I'll be kind of wading through here. Part of the reason that there are so many forgeries around Galileo is precisely that this is a really, really important event, is frequently cited in narratives of the rise of science, or the birth of modernity, or the trajectory of Western civilization. All kinds of different stories use the events we're looking at today as a kind of central pivot point, a day when the world, or a week when the world changed. And that is why it has attracted so much forgery. So it's not like every historian has to deal with all of this junk that I'll be, or stuff that starts off as jewels but is revealed as junk later on. So let me introduce you to some of the actors. Not all historical actors are human. We have Galileo, I hope a figure that doesn't really need much introduction to you. Italian, late 17th century, late 16th, early 17th century, professor of mathematics and then of philosophy, so he makes this kind of movement through the disciplines. And very famously in 1633 is accused of being vehemently suspected of heresy and abjures because of the conflict that's been constructed between religion and science. In the center here we have the one surviving original lens in an original telescope that's now in the Museo Galileo in Florence. And on the right, another of the kind of agents in the story, actors in the story, the book that he produced in the spring, very quickly in the spring of 1610, announcing some of his radical astronomical discoveries. Some more historical actors who provide kind of the context and some of the different routes that we'll be looking at. I hope you can all spot that one of these is an outlier. It's the guy in the rough, yeah. So Paolo Sarpi and Antonio Santini. Santini was not famous enough, for me at least, to be able to find a picture of him via Google. So we've got a different Antonio Santini, a filmmaker. I think he sits well in this company. Paolo Sarpi was a fairly radical theologian who opposed papal authority and kind of guided the Republic of Venice into a heads-on conflict, an ideological conflict, where Venice was placed under interdict for several years. He's a close friend of Galileo's and also a natural philosopher, which is a kind of word that we use instead of scientist because science doesn't exist at this point. But the kinds of activities that we regard as science are in some ways related to what was under the umbrella of the discipline of natural philosophy at this time. Did a lot of important work on magnetism, anatomy, but then devoted himself as a polemical political author. Santini is a kind of bridge between this Venetian kind of ideologically charged group that's opposed to the power of Rome. And so Santini bridges over to Rome, who I've personified here with the rather grumpy-looking Christoph Clavius. Grumpy because he's about to die when these episodes are taking place. Coming to the end of his life, he's the person who gave us the modern calendar, the Gregorian calendar. He made the calculations that in the 1580s shifted the calendar to bring it back into sync with astronomical time. And he's the most important, he's a Jesuit, so a member of a religious order that has a very, very important, powerful university in the center of Rome called the Collegio Romano. And he's the kind of go-to person who authorizes mathematics and physics at this point. So a key player. And then another kind of geographical location, another identity, Cosimo II, a Medici fop. With a Habsburg chin. So a political leader and a patron. And this talk is really about these three locations and these three kind of political authorities, Venetian Republic, the Collegio Romano in Rome, and the power of the Vatican, and the Medici court in Florence, about how Galileo negotiates his way between those three poles of power, and how as historians we can kind of work out his intentions, his strategies, his tactics, as he tries to narrate his discoveries meaningfully to those three locations. So it's a kind of complicated story. You may be familiar with this as mainly active scientists here. What we have here is a calendar from the December 1609 through to the start of March 1610. This was drawn up by Jason Dean at Linda Hall Library. Thanks, Jason. And what it shows is that observation, writing, and printing are all happening concurrently. We sometimes have this idealized notion of the scientist having a very well thought out, you put in your grant proposal, in my first phase I will gather the data, then I will analyze the data, then I will write. I'm glad this is getting a laugh from you, okay? So you recognize that that's not how things work, and it never has been. So Galileo is observing and writing and printing and revising the text all at the same time, all in an extremely compressed period. So 2.5 months from the first lunar observation through to at the start of January, we have the all-important first observations of Jupiter. And then he's looking at lunar cycles and making drawings and writing about that. Printing starts right at the end of January. Printing is complete by mid-March. So these activities that are not discrete, they're all informing each other, and that makes this story quite complicated. What comes out of this, and what's usually been the object that historians look at, is a book. This is not a first edition. This is if it were, I wouldn't be giving lectures. I'd be a wealthy person. So Galileo Siderius Nuncius, this is the English translation by Albert van Helden. As you can see, though, this is more or less actually the dimensions of most copies. It started off a little bigger than this, and then it gets trimmed down. It's a slim book. This has a pretty hefty introduction. It's only a 60-page book, so think of it more as a pamphlet than as something like Newtonian's Principia, which is a big brick of a book. So it's a mobile, short, polemical work. And what we have here, also by Jason Dean, is a breakdown of each section of the book. The letters on the left are the sheets upon which it's printed. So it's printed on 1, 2, 3, 4, 5, 6, 7 sheets of paper. D actually has another half sheet in it. And each of those units makes 8 pages of text. And you can see that there's a dedication to Cosimo II, so not the just to kind of defamiliarize ourselves from contemporary scientific practice. You don't generally dedicate things to political rulers now, I hope. We might have to soon, I'm not sure. Is this being recorded? And then a discussion of how the telescope was invented, a somewhat fanciful one where he says, I quickly mastered the laws of refraction and then I built one. No. And observations of the moon. This is the first part to be written. It seems like this was the original idea of the book, that the moon ceases to be a perfect sphere up there as it should have been in the Aristotelian model, and suddenly becomes terrestrial, or the Earth also becomes like the moon. It becomes mountainous, rugged, full of imperfections, and that by applying mathematical principles to the observations, you can measure the height of the mountains on the moon and make some pretty accurate calculations about what lunar, always confuses me. Do you say lunar geography? That seems wrong, but yeah, right? Selenography? I don't know. What the surface looks like. So that's the first part of the book. And then he points his telescope to the stars and sees way more stars than are visible with the naked eye, and starts looking at things like the Milky Way. And then the real kind of what's become the most radical part of the book, and it's almost half the book, are just pages and pages of, for those of you online, you can't see this, that's helpful, isn't it? Pages and pages of diagrams of using typographical characters of the planet Jupiter and what turn in the course of this narrative into moons orbiting the planet Jupiter. And I don't need to tell this crowd why that's a big deal. the Earth is no longer the center of rotation in the universe. The Aristotelian Ptolemaic cosmos is discredited, and we need a new cosmological model pretty quickly. And that's what happens over the next century or so. Different models are being proposed, and the implications of that, how do we construct a physics that works on a spinning Earth, all those kinds of things, set up some of the main scientific problems for the next few generations. When we open up the book, carefully product placement, used the free access Houghton Library, one of your 2 copies. You see that this doesn't start like we're used to thinking of contemporary scientific texts. It starts with this flowery dedication to Cosimo, where he talks about his destiny, his fate forcing him into these discoveries, as though he's an instrument of God, being guided to the glorification of the inevitable apotheosis of Cosimo as being a really cosmic leader. And in fact, foolishly, without asking, he calls these the cosmic stars. And the book starts to be printed with these being called the cosmic stars. And then he writes and says, like, is that okay? Or should I call them the Medici stars? Because that's a bit more obvious. And gets the answer like, no, actually, we prefer Medici. So most copies have a little sticker over it saying not cosmic, actually Medici. So these kinds of, the dedication of this book show that science isn't just launched to some peer group of practitioners. This is a job application letter in a way. This is a way that Galileo actually ultimately will get out of his job in Padua, where he has to teach students, and gets into a research position in Pisa. We tend to think of this as kind of insincere flattery, but that's an anachronistic concept. This is how science works at this point. And as that is the chain of events that transpired after the publication of this book, we've tended to regard the printed book as the only course of events that could have happened. But I want us to try and think maybe kind of counterfactually, or look at other strategies that are also embedded in the book at the same time. So the textual message is quite clear. Dear Cosimo, give me a job. But when we look differently at the book, we get different kinds of answers. The textual message has been probably most forcefully narrated in this wonderful book by Mario Biagioli, who was here when he wrote it, not here, down the road in the history of science. This wonderful book about how science takes place in court society, and how it's completely, how the way that debates are constructed, the resources that are deployed are completely different to those of contemporary science, but can therefore shed light on what we regard as normal science. That there is no ahistorical way of doing science, there's only ever science in society, and that we're always, as human actors, engaging in, whether we admit it or not, political ventures. Biagioli's work was liberated from a much earlier historiography, which tended to regard science as an inevitable story of progress towards a kind of Enlightenment story, by studies such as, you might be familiar with Thomas Kuhn's Structure of Scientific Revolutions, where you get this idea that science is more of a kind of anthropological, cultural activity, where Greek science is not bad science. Greek science answers the questions that ancient Greeks are asking very well and works perfectly well for them, and that's why it gains credibility. And later studies such as Against Method, where there's this idea that we've kind of over-fetishized the philosophy of science and claimed erroneously that it has a primacy in scientific activity, whereas there's actually a lot more play and serendipity and making shit up as you go along kind of stuff, that's the real condition of scientific activity. So Biagioli very forcefully narrates the transformation of Galileo from reluctant Venetian teacher of mathematics to court philosopher of his patrons, the Medici family, and this research position, no teaching, moving up a scale through the disciplines from math to philosophy. Math is just a calculating device at this point. It can't tell you anything about the real world. It just is about the realm of numbers. And Galileo wants you to have some purchase in the realm of philosophy, which can tell you the nature of the real world. We've probably completely reversed that hierarchy now, right? Philosophers, they're useless, right? So that's kind of one trajectory that leads us towards Florence. A second historiographical, that's the way that history thinks about itself as a discipline. A second kind of historiographical trend also is heavily reliant on the kind of the Florentine story. Its foundation is maybe, there are earlier works, but this is maybe the best read. Erwin Panofsky's Galileo as a Critic of the Arts from 1954. And the argument here is not so much about where science is located, but how science draws on other activities to provide the skills and conceptual vocabulary and sets of practices that allow for scientific progress to occur. So Panofsky writes this beautiful essay saying that Galileo's cosmos was made possible but also limited by his aesthetics. Now, that for us would seem quite a weird claim, although we do still see glimpses of, say, Crick and Watson. You know, it had to be true because it was beautiful, or whatever the quote is about the double helix. Sometimes aesthetic arguments are used. For Panofsky, this was a kind of subconscious category, that because Galileo's artistic taste tended towards non-mannerist art, so he didn't like the twisty bodies of early 17th century art. He liked more traditional round stuff, Virgin with children sitting there symmetrically, and he didn't like the new movement, which was towards distortion and twisting and ellipses and weird shapes. That this informed his cosmology, and so he conceived of he couldn't conceive of, say, Kepler's elliptical orbits. He just kind of refused to engage in that mathematics because he said the universe has to follow this. God designed it, so it has to follow my aesthetics, right? It has to be circles all the way down. All of these people, by the way, would now be classified as intelligent designers, right? Everyone's thinking teleologically and thinking of design. Nobody is thinking of randomness or the atheism is pretty much unthinkable at this point. The most recent expression of Panofsky's work is by a German art historian, very famous German art historian, Horst Bredekamp, who takes this idea of the aesthetic categories a stage further and says that the actual kind of embodied skill of drawing is really key to tracking scientific thought. That he's done similar studies on Leibniz and Darwin. So looking at, say, Darwin's Tree of Life sketch and showing that it's in the act of doodling and in the act of drawing that we learn to conceptualize what it is that we're thinking. The drawing isn't a representation of thought, but rather integral to it. Quite an interesting idea. And there's a lot of great arguments coming out of this field that's now known as visual epistemology. One problem with this is, as I don't have time to argue now, the two documents that Panofsky based his magisterial analysis on are, I think, both forgeries. and I'm not quite sure how we deal, or even though the job of historians of science is basically to look at the history of failed ideas, if you conceive it that way. On a depressing day, that's what our job is. It's hard to know what you do when your discipline does great work, even though the premises are then pulled away. And so that'll be a later paper to work out what to do with Panofsky and what to do with the subsequent scholarship that's based on Panofsky's work. The insistence on the primacy of the visual and the self-confidence of art historians in saying, like, it's the visual culture is what we need to understand, and that will then elucidate other kinds of scientific activity, have sometimes led to some pretty spectacular mess-ups. So in the case of the Siderius Nuncius, this is what Martin was alluding to. The printed book contains these etchings that are of some of the phases of the moon. When you print a book in the 17th century, for technical reasons, the etching, it's a different kind of printing. So the page has to, the sheet of paper has to go through a press, different kinds of presses for the words and for the pictures, if they're etchings. If they're woodcuts, it's okay, you can print them together. But etchings need a different press, just trust me on that. And you can actually see here that the edge of the plate overlaps the lower line of text there. And that relationship shifts around from copy to copy of image and text. In a few copies, probably about somewhere between 20 and 30 copies of the Siderius Nuncius, and books. This book was printed in 550 copies. We know quite a lot about this book, way more than we do about most 17th century books. So in about 5% of the copies, they forgot to put it through the press a second time, and so they're just blanks. It says, look at the picture of the moon here, and there's this long discussion. And so this reader's like, all right, I'll draw it myself. Got hold of probably a different edition, probably a German reprint, and drew in the image there himself and then annotated it. In 2005, this copy appeared in, this is one image of the copy, so a complete book bound up with other Galileo works. It has an inscription in it saying, I, Galileo did this. It has library stamps from the Lincean Academy, which is the first scientific academy in Italy, of which Galileo was elected a member as a result of this book. And it has these washes of the moon, so watercolor pictures of the moon. And that same historian, Horst Bredekamp, did a very in-depth analysis with a team of experts where he proved that this was Galileo's own copy and that these images were the basis for the etchings. So a $10 million book right there, until I came along and said, what is that odor? And it turns out that this was a forgery made in about 2004 by an Italian forger, Massimo De Caro, one of a whole string of forgeries that he'd done. So perhaps unfairly, I point this as a kind of cautionary tale for those who overinvest in the campaign for the primacy of images as the source for historians of science. One of the kind of unintended consequences of Bredekamp's work has been to displace other historical sources from their primacy. So we're now entering, BNCF is the Biblioteca Nazionale Centrale di Firenze, which means the big library in Florence. And they have about 350 volumes of Galileo's letters, letters sent to him, letters from him, stuff about his family before he was born, stuff from his disciples. It's the biggest archive of Galileo material in the world. And here we are in Galileo number 48. which is a dossier that was put together not by Galileo himself, but by later archivists, where they assembled together basically the working material that would become the Sidereus Nuncius. And this, so this is a reconstructed folded sheet, is a very thick paper, and it contains these images of the moon that closely resemble the ones that then show up in the Sidereus Nuncius. Also can very nicely to get us to think about what it is that scientists believe and do. Contains a horoscope. There's a horoscope included in the Sidereus Nuncius that this is Cosmo II's birthright, his destiny to have these moons discovered and named after him. Horst Bredekamp's insistence that that forged copy was the real thing, was the moment when Galileo sat there and drew the moon from actual observation, meant that he had to discard this. So he said, we have no idea whether this is even Galileo and when it entered the archive, and it could have been much later, and we don't really know anything about this, so we can ignore this, look away from this and look at the new shiny artifact. So even within an archive, sometimes we have these movements by historians that can displace canonical objects. The rest of that volume, Galileo 48, contains a series of quite wonderful texts. So we actually have the manuscript, the autographed draft, it's more than a draft, of most of the Sidereus Nuncius. This is actually the copy that the book was printed from. At times there are little marks in there saying, we need to start a new sheet of paper here. So things that an author wouldn't be concerned about, but a printer would be. And you can see it's really, really messy. So again, whereas we might think like nothing goes, we want our archive to reflect our actual final result. There is also in this dossier an attempt to write it out in neat handwriting that doesn't get very far. But this is the text as it's being written, with all the crossings out, marginal additions, all that stuff. And this is what the printer's actually using. Weirdly, nobody's ever gone through this and provided a transcription or done a critical edition and shown how it differs from the text that became public. It's as though we have Hamlet in Shakespeare's handwriting, and all the English professors said, that's not important. We've got the first folio. We're fine. So somebody somewhere should do, maybe me, I'm not sure, should do an edition of this amazing text, because you can see it, the rethinking, the work in progress at every stage. Also in this volume are some observational notes that seem to be early drafts. So this is especially of the discovery of the satellites of Jupiter. Left-hand side here, I should have faded this in so I didn't give the game away too early. I've ruined the story already. We have in Italian, not in Latin. The Sidereus Nuncius is written in Latin. The other side of this sheet of paper suddenly switches to Latin as he realizes he's on to an international important book. But what seems to be the personal notes here are written in Italian. So it starts off on the 7th of January, 1610, Jupiter looked with the telescope to have 3 stars that are like this up there. And then he goes day by day saying when it's cloudy, charting out what's happening with this planet and these troublesome stars that don't seem to be just sitting in the background like they should be, but seem to be hugging Jupiter and dancing around in weird ways, until on about, already on the 11th, he seems to have an inkling that the only way of making sense of this is to think in terms of a moon system. Itself an enormous jump in the imagination. So this document has also had a kind of primary status. You might have seen this reproduced in histories of science, but it's often accompanied by or replaced by this document. You can see the top half is a draft of a letter, Dear Prince. It's a letter to the Doge of Venice, not Doge as in Musk, Doge of Venice. We have the sent version from the summer of 1609 when he gives the gift of the telescope to the Venetian Republic. And then he stops. He's made too many mistakes. He knows he can't send it, so it's just a draft. It gets aborted. And then 6 months later, happens to pick up that same piece of paper and in exactly the same ink starts writing, oh, on the 7th of January, Jupiter's like this. Now, this document, the first trace of it is in the 1930s. It was then given to, bought by a collector, then given to Ann Arbor, University of Michigan Special Collections. It was rediscovered in the 1960s by the great Galileo scholar Stillman Drake, who's really excited about it because he said, this is the precursor to that. This is the real thing. This is the looking through the telescope nightly observations. This is when he's realized he's onto something, starting to flesh it out, draft number 2, working towards the book. So this becomes the most important document in the history of the scientific revolution. It's got some really weird things. I write a lot about Galileo, and I was curious about this because it's such a wonderful document, but it started not to make sense to me. If you Google when were arrows invented, not really, but metaphorically, to imply motion, weirdly, an art historian wrote an article about this, happily for me. 1730s, the first arrows to show motion, so vectors, forget them. So weird anachronism, you don't see any arrows there, but and so historians of science didn't really grapple with that and took this to be the original text. I came along in my bull in a china shop way and said, could I have a closer look at that? And I asked them to shine a light through the paper. And when you shine a light through the paper, what you get to see is the physical structure of the paper. You see this is a watermark, so that's fine, but you can't really see this very well. But trust me, I know those words are being discredited by someone. Trust me. It says ASBMO, upside down. You might be able to see the BMO. Oh no, at the top, sorry, BMO, and the AS is here, that's right. And that is basically like an airport code for the city of Bergamo. I mean, not literally airport, but it's an 18th century paper taxation requirement that they say where their paper comes from. And if you look, because people have done this, at papers from around, you can date papers from the content and style of their watermarks. No paper before about 1740 has these kinds of watermarks in it. And so it's a little troublesome to find a document written in 1609 on a piece of paper that was made in 1740. For a historian, at any rate. So this turns out to be a forgery by a very notorious Italian forger, Tobia Nicotra, and University of Michigan has been great, no resistance to this argument, and now exhibits it as a forgery. But just last week, this is this is NASA's news blog, January 8th, 2025. There it is. I got on the front page of the New York Times with this, and still it appears as a genuine document, even though it's clearly discredited. So the work of the historian, even when you do all this detective work, it can be very hard to displace the forgeries. It's relatively easy to displace the real stuff, but getting rid of a forgery can be a lot of work. If we look now at another level, so that's kind of the Florentine scenario done looking at what the text says and what the text shows. If we look kind of at the materiality of the text, we find some quite surprising stuff. So even though the text says that it's printed in Venice by Thomas Baglioni, it turns out that he wasn't really a licensed printer, and that he worked for a guy who was a licensed printer, a guy called Roberto Meietti. But Meietti's name is not on this document because he's been burnt in effigy in Rome for producing Paolo Sarpi's polemical anti-Vatican pamphlets. So we see here a kind of a veiled strategy where Galileo is choosing precisely the printers that the Republic of Venice has decided it's going to be using for all of its polemical literature. And there's a kind of encoding here of a kind of subversive, a message saying, you know, I'm with Sarpi, I'm with Meietti. This is one of those. This is one of those pamphlets. You know, this is part of our polemical war. So the text level, one message; material level, another message. There's another document which has not received a whole lot of focus because it's so difficult to make sense of. It exists in two copies. This is an 18th century copy of the end of it. You see there are sketches of the moon. If we were to look earlier, you'd maybe see show through there on other pages. There are sketches of the phases of the moon there that resemble very closely what then turns into the Sidereus Nuncius. And a lot of the prose, a lot of the terms that are used about the ruggedness of the moon, the coarseness, the mountains, the valleys, islands and inlets, all of this vocabulary, this new lunar vocabulary, or rather translation of terrestrial vocabulary mapped onto the moon, is in this letter. And these are not words that Galileo usually uses. So he's trying to think himself onto the moon and think, what would it be like to be standing on the moon, and what can I see? How would it make sense to somebody who's used to being on Earth? And the shocking news is it would look remarkably similar. He thinks that there might be seas there, rivers. There's a big discussion between him and Kepler about whether there are built structures, all of that kind of stuff, whether there are weird lizard men. That's what Kepler thinks. Galileo's like, knows that that's a fairly dangerous thing to start thinking about because there are all kinds of theological implications about lizard men. And so this is the 18th century version of this letter. We don't know who this letter was sent to, but it's dated, not in this version, but in another version I'll show you in a minute, to 7th of January 1610. So it's that first night when he starts to look through the telescope and describes all the lunar phases, the terrestrial nature of the moon. And then in this copy it stops, but in another copy he carries on and says, oh, and I've just started looking at Jupiter, and there are these 3 stars in a line. And then he sends the letter that day. So he doesn't wait, as he does in the observation log, to make sense of what these dots are. He probably thinks that they're still fixed stars in a line. But he's struck by the fact that they are very, very bright, very close to Jupiter, and in a line. And so it's as though it's a kind of note to go back to that observation the next day. This is in Florence, this later copy. It's not the original of the letter, but it's a 17th century copy. Was reproduced in the big edition of Galileo's works that was done just over 100 years ago by the great Italian editor Antonio Favero, who basically brought together 20 volumes of Galileo stuff, volumes and volumes of letters that hadn't ever been published before. And when he asked, he knew that there was a reference to this letter sitting somewhere. He got a photograph in 1903, I think it was, of this document, and was just told it's in the Vatican. Not going to say where. That's very slightly more helpful now, but not much. We have this document. Here's an image of it. And it turns out that this document had never been traced after that. Everyone had used this reproduction that Favoraux had. He transcribed it. He reproduced these images. They came out very badly in his printed edition, just kind of black and white images. And then about 10 years ago, this resurfaced. And it's actually in APUG, which is, you're learning so much today, the archive of the Gregorian University in Rome. That's the Jesuit University in Rome. And APUG 530 is a volume, one of two volumes of the correspondence of that Jesuit mathematician Christoph Clavius. So its archival location is really interesting. What's this document doing amongst Clavius's personal papers? We have no evidence that these were ever reassembled, shuffled around. Pretty much everything in there is from Clavius's lifetime. There might be a couple of things from after his death, but not much. It says, your most affectionate servant, Galileo Galilei. This is the end of it. We know it's not written by Galileo to Clavius directly because A, it's not in Galileo's handwriting, although when the Gregorian rediscovered this, they said the signature is definitely Galileo's autograph. Not at all. But it's not addressed to your reverend father, which is the way that you would address Clavius. It just says, "Dear Sir." So it's a very puzzling document. And nobody's really been able to make sense of it. Antonio Favoraux, when he edited it, said that this is probably was written for one of the Medici. Couldn't really explain how it had ended up in the Vatican, but maybe, maybe he didn't know where it was in the Vatican, so it could have been part of somebody else's collection. And it's been a bit of a kind of dead end. Yeah, the big reveal. If you look at the sign-off there, and look through everyone else who's writing to Galileo at this period, the flourishes of the servitore affettuosissimo, most affectionate servant, are those of Galileo's close friend and confidant, and also correspondent of Christoph Clavius, this guy Antonio Santini, the one I didn't have a picture of, right, at the start. So what this means, I think, is that Galileo wrote up on the 7th of January, fresh from just having seen what he didn't yet know were the satellites of Jupiter, wrote up this tract as a kind of priority claim, right? I'm telling you, you are now the recipient of a letter that says the moon is mountainous. This is basically a draft of what he thought at that point the Sidereus Nuncius was going to be. He didn't realize that half the book was going to be revealed by closer analysis of what he saw in that final sentence of there's Jupiter and some stars next to it. So he sent it, I think, to Santini, and Santini thought, right, there's no he didn't. This is an anachronistic thought. There was no repository for filing away a scientific claim. You can't, there are no Royal Society logbooks where you can go along and say, I'm staking this claim, this isn't a patentable thing. But he thought, where would this knowledge be archivally safe, and who could I trust, and who's going to understand the importance of this document? Who needs to know this before anyone else? Christoph Clavius. So whether it's Galileo saying, I as a Venetian subject, or Tuscan subject working for the university, I'm not quite sure where his allegiance lies in this, cannot, like I'm legally banned from writing to a Jesuit because Venice is under interdict at the moment. I can't reach out to this guy. If I were to write you a letter, could it be possible, might it possibly happen that you would, that a copy could find its way to Clavius? And I think that that's what Santini understood this letter to be, that this was meant to go on file, start the campaign to convince Clavius that his university textbook that he'd been going through edition and edition of, Sacrobosco, needed a revision. And in fact, the next final edition of Clavius's textbook ends with a section saying, oh, Galileo's just written this book where that requires a pretty substantial rethinking of cosmology. So what we see here, I think, is a kind of triple strategy amongst enemies. Right? Florence and Rome are not on great terms. There's political tensions there. Florence and Venice Florence is a kind of minor power that's a kind of buffer state between Milan and Venice and Rome. Venice and Rome are practically on the verge of war. I mean, they're starting to mobilize troops. It's that serious a conflict. If we were to look a little further ahead, we're just on the cusp of the 30 Years' War, and most of Europe will be involved in armed conflict before the decade is out. What we see is that Galileo is trying to send some kind of, get his message into each of these potential audiences using different modes of communication. So to Venice, he says, I'm publishing with your printer. This is one of, this is my sign of allegiance to you. On the other hand, he's also dedicating the book to the Grand Duke of Tuscany. And then on the third hand, he's also sending this kind of private, secret correspondence through to the Jesuits. So what I want us to think about, I just read this novel recently, The Ministry of Time. Anyone read that one? Great book. It's good, right? Yeah. Ministry of Time by Kellyanne Bradley. Contains this wonderful sentence. Everything that has ever been could have been prevented, and none of it was. Love that. I love that. I think that's a really important kind of way for us to think of history. We're always trying to work out what were the counterfactuals, what's enough of a reason for something to happen, but how could it have gone otherwise, and why didn't it? We've often, as historians, kind of despite our own insistence that we're not teleological thinkers, we're not presentists, we're not trying to explain how the modern world came to be. We're trying to explain how other moments in time were on their own terms. We often still smuggle in results as causes and say, because this chain of events took place, that's the narrative. Those are the documents that we'll look for that will explain how that happened. And what I think we see in this case is that even in a single moment of time, there can be multiple contradictory strategies coming from the same actor towards different audiences, and multiple event sequences being mapped out. Galileo is basically backing all the horses simultaneously in a race. But also, I think, the time frames with which we do history really matter. If we were to, one of the reasons why we're perhaps surprised to find Galileo's first account of telescopic observations, that's what this is. This is the first thing that he sends to anyone, saying what he's seen through the telescope. We might be surprised to find that in a Jesuit archive, given that what we know happens 20 years later. There's a trial. The Jesuits are really, really incensed at Galileo. So are the Dominicans and other religious orders as well. But we know that, or what we think we know, is that there's a massive conflict between science and religion that Galileo kind of stumbles into or engineers. And so that event, when seen in the framework of the immediate aftermath of the trial, is an absolute catastrophe for natural philosophers. They say, this is like Socrates committing suicide again. This is the outcome of this trial is awful. This is the end of science. Sound familiar? Nowadays, though, using a different time frame, we say, well, maybe not nowadays. 5 years ago, 3 months ago, we would have said, actually, science is the most powerful force in the universe to describe reality and predict reality. Science wins. What we're witnessing in the Galileo trial is actually the last kind of dying gasps of medieval superstition. That was the narrative of the 19th and a large part of the 20th centuries. And so the question with which I'll end is, who is Galileo going to be in the 21st century, and what is science going to be? That's all I got. Thank you.
Thank you very much, Nick. That was a lot of fun. Do we have a few questions? Yes, please. Oh, Karen.
Yeah, no, thank you so much.
I should give you the mic. Sorry.
Thank you so much. So many questions, but maybe start where you ended. So when you say that this was sort of a disaster for science, the trial, was that how it was seen at the time? I mean, I'm thinking about Galileo famously inventing sort of modern physics in the sort of coming decade. Like, what was the perception at the time, or how much of this is us, again, projecting back?
There are contemporaries who explicitly say this is the trial of Socrates. Like an astronomer in the south of France, Nicolas Claude Fabry de Peresque, he actually writes to one of the cardinals and says, it's not too late to reverse your decision here. You can, this isn't yet a public fact. Like, you could walk away from this. What you'll do is destroy any freedom of philosophy. If what you do is insist that the theology always gets to trump, no pun intended, natural philosophical investigation. What Galileo had said, I mean, perhaps, well, is it my job to judge? Seems so. Galileo had said that if there's a theological truth and a natural philosophical truth that came into conflict, then the theological truth had to back down and become a kind of metaphorical statement, because the scientific truth had to be true. Whereas there are many examples in Scripture of things that sound as though they are actual literal statements that we now understand to be figurative speech. And so what the church is doing is saying, you don't get to tell us how theology relates to natural philosophy. Actually, theology is the most secure form of knowledge, then philosophy. Natural philosophy and mathematics is way down below. And now we flip that, but what I'm trying to think through now is how secure is that hierarchy, and what happens when it's seriously challenged. I mean, we're living in a society where higher education is deeply distrusted. We've obviously, I don't really like the self-flagellating mode, but in some way we've failed to message competently a narrative of the intrinsic value, not the commercializable value, not using utilitarian arguments or space fantasy arguments, but just like the value of knowledge in itself. That doesn't seem to be being believed in this country at this moment by enough people. Dodging bullets. So how did I get there? So I'm just trying to kind of think through like where else in history has those tensions been this apparent, and what happens, and how can we make sense of them? And there's no real happy take-home message like you can embed your message in different ways to different audiences and basically like dissimulate your way to secure grant foundations that apply to the Templeton Foundation for everything. I'm not sure what the answer is at all, but I just think that the thinking of science as an inherently political debate is not to give up the ground, it's to really kind of affirm where and why knowledge is created and why it's meaningful. That was a long, weird answer.
We have another question over here.
About this roundabout letter to Christopher Clavius, Galileo stopped this after the after the observations of the moon, you said. And so after he discovered the satellites of Jupiter and everything, did he follow up, or did he figure that the book is already printed, so no need to?
He does subsequently contact Clavius, and he does a kind of victory trip to Rome where they are another cardinal who's interested in this, precisely this question of the relationship between theology and natural philosophy, asks, who's a Jesuit, Cardinal Bellarmine, asks for the Jesuits who are, at that point, have got hold of telescopes, whether the truth claims or whether the claims are correct. There's a lot of, when the Siderius Nuncius comes out, a lot of people say this is hallucination. This is, I've looked through a telescope and I see all kinds of flares around objects. Well, you've probably all seen this yourselves. Like there's no reason to trust this. And there's definitely, even if we were to trust it as a terrestrial, say, military weapon, the idea that it could stuff up there, which we know is physically different, in that we don't know what it is, but it's made of different stuff. It's not a reliable instrument. So there's this initial, depending on location, depending on kind of ideological commitment, there's a lot of pushback against Galileo. But he does go to Rome, and most of his claims are replicated, validated. And so there's this kind of honeymoon period where it seems like that letter to Clavius was probably a really good idea. Although friends of his in Rome also say, like, Clavius isn't convinced, he's laughing about this, he thinks that those satellites are a joke. So we've really got knowledge being a kind of epistemological flux going on for a while that requires quite a long negotiation and the right sources of credit applied for it before it can become fact.
We're nearly at the end here, I think so.
I just have one question to follow up on what you and Karen were talking about the trial. So Owen Gingerich once corrected me when I said that Galileo was in trouble for believing this. And he said, no, he was in trouble for teaching this. And that what the outcome of the trial was to ban him from promulgating and teaching this idea. But obviously he sat around and did all kinds of great work back in our Chetri. So what do you think that means for the modern situation? In other words, are we being gagged and we can keep doing what we're doing? We just have to speak carefully? Or what do you think?
Leading question.
I think we're definitely being gagged, but I think that gagging stops us doing what we're doing, because part of establishing a fact is making it publicly true. And so that distinction might have made sense for the Catholic Church, but it doesn't make sense for modern science. So shout louder.
Do we have time for one more question?
I'm happy to.
I think Charles was first.
So another feature of modern science is replicability. Mm-hmm. So who was the second person to make these observations?
Santini. Santini is actually the first person who independently sends, at least for the satellites of Jupiter. So for the moon material, other people had actually seen it before Galileo. Thomas Harriot in England, most famously, although he saw very different things. He saw seas and coastlines because he'd been to Virginia, and so and mapped. So he was a mapper. So he saw cartographic visual realities. Santini is the first person to actually put into writing, I too have seen this. Very strangely, Johannes Kepler receives a copy of the Siderius Nuncius and instantly sends Galileo a letter and rushes into print saying, you have no reason to lie, I believe you, before he's had a chance to look through a good enough telescope. It's a very strange response from probably the most important astronomer alive at that point. And it's not quite clear to me why he decides to go all in with Galileo. It takes him a few more months before he gets hold of a telescope. There's also a very interesting, there's disseminating the book and the message of the book, but disseminating the mode of replication is a completely separate economy. Mario Biagioli's brilliantly argued that Galileo consciously doesn't send his telescopes to people who he thinks might discover what else there is to be discoverable before he's done it. Right? So he has completely different maps of distribution for the telescope, and so he doesn't want Kepler to have a good telescope. But he kind of does need the Jesuits to have a good telescope, because he doesn't think that they'll discover more. He just thinks that they'll see what he's seen, because they don't want to shake things up too much. So there's some replicability is a really interesting issue. And then you get people saying that, oh yeah, I saw that years ago. Oh yeah, I invented the telescope 20 years ago. We've been doing that forever. There's nothing new here. You get a lot of kind of undermining. And you get people saying, I looked really hard through the telescope and I saw completely different things. I saw four little dots around anything that I looked at. So that's all you're seeing. You're seeing instrumental hallucination, nothing else.
Right.
Okay, so Galileo did get along with people in the church at various, I mean, there's politics in the church going on too. So how did the people he had gotten along with, how did they deal with his science, or what he was doing?
So importantly, there's a great book by recently deceased historian of science, John Heilbrunn, called The Church? The Sun in the Church. Sun in the Church, thank you. Hannah Marcus, historian of science here at Harvard, knows way more than I do about all of this stuff. The Sun in the Church by Heilbrunn. Heilbrunn argues that the church is physically, as well as institutionally, the most important location for natural philosophical knowledge production for the 15th and 16th and into the 17th centuries. They're using cathedrals for charting meridian lines. They're measuring the universe. These are basically the only structures that are stable enough and big enough and have the institutional longevity to be able to accurately serve as what we now think of as observatories. So the church is doing science, doing natural philosophy, is not opposed to it at all. It's really this question of where that leaves theology that is tackled in different ways. And we shouldn't think either that this is just a kind of a Catholic atavistic like throwback. Luther's one of the first people to say, that the Copernican thesis is totally ridiculous. Goes against God's divine order. So there's opposition from all kinds of theological positions, and there are, I think it's fair to say, no non-theological positions. Some people have tried to carve out a special space for Galileo and say he was a closet atheist. I don't think he's particularly pious. He does get people chasing him up for not going to church on Sunday. He has kids out of wedlock. Fairly standard Italian behavior. But I think he would generally and genuinely say that God created the universe. He's not trying to, he's no Darwin. He's not thinking of a non-teleological, godless universe, if even Darwin was capable of really doing that.
Excellent. I think perhaps we better draw it to a close here and thank Nick one more time.